Greetings, and welcome to our exploration of one of the universe's most enigmatic phenomena, black holes. These mysterious entities have fascinated scientists and stargazers alike for decades, and today we will delve into their secrets. Imagine a place where gravity reigns supreme, so strong that not even light, the fastest entity we know, can escape its clutches. This is the realm of black holes, where the laws of physics as we know them are pushed to their limits. These celestial objects, shrouded in darkness yet capable of warping the fabric of space-time itself, are black holes. They are regions in space where the gravitational pull is so intense that nothing, not even electromagnetic radiation, can break free. These aren't merely empty spaces, but regions where immense amounts of matter are crammed into an incredibly tiny volume. The density of a black hole is beyond comprehension, with matter squeezed into a point known as a singularity. Think of a star, many times the mass of our sun, compressed into a space smaller than a city. This process often begins with the death of a massive star, which undergoes a supernova explosion, leaving behind a core that collapses under its own gravity. That's the incredible density of a black hole. The core, or singularity, is a point where density becomes infinite, and the known laws of physics cease to function as we understand them. Black holes are not all created equal. They come in a range of sizes, from stellar mass black holes, which are formed from collapsing stars, to the supermassive black holes that reside at the centers of galaxies. Some are relatively small, perhaps a few times the mass of our sun. These stellar mass black holes are scattered throughout the universe, often found in binary systems with other stars. Others, lurking at the centers of galaxies, are supermassive giants, millions or even billions of times heavier than our sun. The Milky Way, our own galaxy, harbors such a behemoth at its core, known as Sagittarius A*. But how do these cosmic monsters form? The formation of black holes is a complex process that can result from the collapse of massive stars, or through the merging of smaller black holes over time. What happens when something gets too close? Objects that venture near a black hole are subjected to extreme gravitational forces, often being torn apart and forming an accretion disk as they spiral inward. And what can they tell us about the universe we inhabit? Black holes are not just destructive forces. They are also key to understanding the fundamental nature of space, time, and gravity. The study of black holes has led to groundbreaking discoveries, such as the detection of gravitational waves. Let us venture further and unravel these mysteries together. As we journey through the cosmos, we will explore the profound impact black holes have on their surroundings and the insights they provide into the workings of our universe. Join us as we dive into the depths of these fascinating cosmic enigmas. The life story of a black hole, much like the stars they often originate from, is a tale of immense forces and dramatic transformations. These cosmic behemoths are born from the remnants of massive stars, undergoing a series of violent and spectacular events that ultimately lead to their creation. Imagine a massive star, one that is many times the size of our own sun, nearing the end of its life. This star has spent millions of years fusing hydrogen into helium in its core, a process that releases an immense amount of energy and creates an outward pressure that balances the inward pull of gravity. As the star ages, it exhausts its nuclear fuel. The outward pressure from nuclear fusion can no longer withstand the relentless inward pull of gravity. The star begins to expand and contract in a desperate attempt to maintain equilibrium. But this is a losing battle. Eventually, the star's core collapses in on itself, triggering a cataclysmic event known as a supernova. This explosion is one of the most powerful events in the universe, outshining entire galaxies for a brief moment and sending shockwaves through space. During this collapse, the core is crushed into an incredibly dense and infinitely small point known as a singularity. The gravitational forces at play are so intense that not even light can escape from this point. This singularity is shrouded by an invisible boundary called the event horizon. The event horizon marks the point of no return. Once something crosses this boundary, it is forever trapped by the black hole's immense gravitational pull. Anything that crosses the event horizon, be it a planet, a star, or even light itself, is trapped forever, destined to be consumed by the black hole's insatiable gravitational appetite. The black hole grows as it devours more matter, becoming an even more formidable force in the cosmos. This extraordinary process, the death of a giant star giving rise to a black hole, is a testament to the universe's awe-inspiring power. It is a cycle of destruction and creation where the end of one celestial body leads to the birth of another. But the idea of black holes wasn't always readily accepted. For centuries, the concept of an object with such immense gravitational pull that not even light could escape seemed like pure science fiction. It took centuries of scientific inquiry, from the musings of an English clergyman named John Michell in the 18th century to the groundbreaking theories of Albert Einstein in the 20th century, for these celestial objects to move from the realm of speculation to scientific reality. Michell first proposed the idea of dark stars in 1783, but it wasn't until Einstein's theory of general relativity that the true nature of black holes began to be understood. Today, with the help of advanced telescopes and observatories, scientists continue to study black holes, uncovering new mysteries and deepening our understanding of these enigmatic objects. The birth of a black hole is not just a dramatic event in the life of a star, but a profound chapter in the story of the universe itself. As we peer into the depths of space, we are reminded of the incredible forces at work, shaping and reshaping the cosmos. The birth of a black hole is a powerful reminder of the dynamic and ever-changing nature of the universe. And so, the story of a black hole, from the death of a massive star to the creation of a singularity, continues to captivate and inspire, revealing the profound and awe-inspiring power of the universe. Given their inherent nature, directly observing a black hole seems like an impossible task. After all, how can one see something that devours light itself? Yet astronomers have devised ingenious methods to detect and study these elusive entities. One method relies on observing the effects of a black hole's powerful gravity on its surroundings. As matter spirals inwards towards the event horizon, it heats up, emitting intense radiation detectable by telescopes. These swirling masses of superheated gas and dust are known as accretion disks and serve as telltale signs of a black hole's presence. Another method involves studying the motion of stars orbiting an invisible massive object. By carefully analyzing the star's trajectories and speeds, astronomers can infer the presence of a black hole, its mass, and even its spin. It's akin to deducing the presence of a powerful, unseen dancer by observing the intricate movements of its swirling partners. These indirect methods, while effective, provided only circumstantial evidence. The dream of capturing a direct image of a black hole, a visual confirmation of its existence, remained elusive for centuries. In 2019, the world marveled at an image that forever changed our understanding of black holes. This image was not just a scientific milestone, but a moment that captured the imagination of people around the globe. It was a testament to human curiosity and our relentless pursuit of knowledge. A team of astronomers, using a network of telescopes spanning the globe called the Event Horizon Telescope, EHT, achieved the seemingly impossible. They captured the first ever image of a black hole. This network of telescopes, strategically positioned in various locations around the Earth, worked in unison to create a virtual telescope the size of our planet. The coordination and precision required for this endeavor were nothing short of extraordinary. This wasn't a photograph in the traditional sense, but a reconstruction based on immense amounts of data collected by the EHT. The data was so vast that it had to be stored on hundreds of hard drives and physically transported to central processing locations. Scientists then used sophisticated algorithms to piece together the data, creating the now iconic image. The image depicts the supermassive black hole at the heart of the galaxy Messier 87, M87, located a staggering 55 million light-years from Earth. This galaxy, M87, is one of the most massive galaxies in the nearby universe, and its central black hole is several billion times more massive than our Sun. The image reveals a bright ring of light, a halo of gas swirling at incredible speeds around the black hole's event horizon. This glowing ring is caused by the intense gravitational forces at play, heating the gas to millions of degrees and causing it to emit light. The dark central region, the shadow of the black hole itself, represents the point of no return, where gravity reigns supreme. This shadow is cast by the event horizon, the boundary beyond which nothing, not even light, can escape the black hole's gravitational pull. This groundbreaking achievement provided concrete visual evidence for the existence of black holes, confirming Einstein's theories and ushering in a new era of black hole research. It was a moment of triumph for the scientific community, validating decades of theoretical work and opening up new avenues for exploration. However, this is just the beginning. The image of the black hole in M87 is only the first step in a long journey of discovery. Scientists are now looking to capture images of other black holes, including the one at the center of our own Milky Way galaxy. The study of black holes is a journey into the universe's most extreme environments, offering insights into the fundamental laws of physics and the evolution of the cosmos. As we continue to explore these enigmatic objects, we may uncover answers to some of the most profound questions about the nature of space, time, and the universe itself. The quest to understand black holes is not just about looking into the darkness, it's about illuminating the very fabric of reality.